So this is question number 4 from the book Pathfinder, chapter kinematics, subsection challenge your understanding. An L-length long, thin tape wound on a spool of radius r0 makes a tape roll of outer radius capital R. A motor used to wound the tape rotates the spool at a constant angular velocity and takes a capital T time to complete the winding. Calculate the length of tape which has been wound in time small t from the beginning of the winding. So in this question, there's a spool on which a tape is being wound. And when L length of tape is wound over it, its radius becomes capital R and it takes time as capital T. Now the question is when in time small t, in some other time, what will be the length of tape that will be wound over it? Okay, so let's see how to solve it. So in this question, there is a spool of radius R0 and there is a tape which will be wound over this spool, and as this tape will be wound, the radius will gradually increase. So suppose the radius has increased to a new value denoted by small r, and the spool is being rotated with the help of a motor with a constant angular speed omega, and some length of tape is already wound and some is still to be wound. So this much of tape is still to be wound, and consider the rate with which radius is increasing at the instant when the radius itself has become smaller. So with what rate will this increase? So for that, first see omega over 2 pi is the frequency, means these many turns will be wrapped in 1 second, omega over 2 pi, and these many turns will increase the radius by how much amount? So if the width of tape is d, then number of turns into d. So this much of thickness will increase, and that will be the rate of increase of the radius. Rate means per second, and omega by 2 pi is the number of turns covered per second. So this is how it matches unit wise. On both sides, I have written quantities per second or per unit time. So when number of turns and width of tape is multiplied, so that gives the total width that will increase this radius r. So that is dr by dt. So this is the expression, and from here, notice that this rate of increase of r is independent of r itself. That is, it is a constant. So r is increasing with a constant rate. So therefore, we can write r as a function of time, as a linear function of time. R0 is the initial radius and it is increasing with time linearly. And it's given that at after a time capital T, radius becomes capital R. So put the values, and this will give the value of constant. Put back the value of constant in the expression of R. So finally we have the expression of R as this. Now, L into D, this is the area. L is length, D is the width of tape. So this is the area of tape which is wrapped when total L length is wrapped. So this area will increase the radius when it is wrapped. It will increase the radius from R0 to capital R. So this will increase the area from pi R0 square to pi R square. So increase in area when wrapped is equal to the area of tape that is to be wrapped. This equation is clear. LD is the area of tape that is to be wrapped. And when it is wrapped, the radius becomes from R0 to capital R, and therefore area increases from pi R0 square to pi R square. So this is net increase in area, which is equal to the area of tape. Okay, so this equation is clear. When X length of tape is wrapped, then suppose the radius increases from R0 to R, then we can write a similar equation for this condition. When X length of our tape is wrapped, so that is the area wrapped, and it will increase the area of spool. So taking these equations and solving it, let us see. So we have this expression for R. We have one expression for total length of tape wrapped. We have one expression for X length of tape wrapped, And if we divide these two expressions, we have this expression, and we have to find uh, what length will be wrapped in a given time. So from here we find the value of x. And now, since time is given in the question, what we can do, we can first find the value of r in that time, and putting the value of r here, we can find the length of x that is wrapped in that time. So simply put the value of r in terms of time and then solve it to get the length of tape which is wrapped in time t. Okay, hope you enjoyed it.